Hey there, so in this video I want to go over part 3 of Hooke's Law. It can be a little confusing because the problem is like a puzzle and they're trying to get you to apply the ideas that we know in Hooke's Law in order to solve this kind of sciencey puzzle. So it's kind of fun. So I'm going to walk you through. I'm going to give you some hints on how to attack this one. All right, so first things first, we got to make sure we read the instructions really well. So we're going to apply this law to a new situation. So in the picture below, we have 3 springs. In the first picture, all 3 springs are at equilibrium with no weight attached. So that means they're going to be sitting at their natural length. Okay. Springs 1 and 2 are identical. So we know they are the exact same. And so we want to create a data table below for springs 1 and 3. And then determine the spring constant using the same process used above. So just like what we did earlier in the lab, we want to create a data table of length expanded compared to the force applied. That will allow us to find the K value for each spring. Okay. The mass attached to the object is given, and you will need to convert that weight before graphing. So we're going to do that piece. Then the last part is we want to write an equation for each graph. Finally, in part 3 here, we have a new picture with our 3 weights here, and they're unknown weights. And so we want to use that spring constant in order to figure out what the unknown masses are. So without further ado, let's kind of talk this through. All right. So focusing in on this left picture here. So here we notice we have all the springs here are sitting there with no mass attached. So this would be the natural length. This is their resting position. So notice they all have this resting position of about, it looks like 31 centimeters. So 31 centimeters there, okay? All right, so now if we come over to this first picture, we know that spring 1 and spring 2 are identical. So let's just focus on 1 and 2 to start. So here if we put a 50-gram mass on, we see that the spring stretches to about 36 centimeters. So again, I'm just looking at the picture. It stretches to 36 centimeters. I could, again, just like earlier in the lab, we can use Hooke's Law, F equals negative Kx, where we can then calculate the value of K based on how far it's stretched and how much mass has been put on. Okay, so on the third picture, here we've added 100-gram mass. So we've increased it by double there for the mass. And now notice we are, it's in between 40 and 41. I'm going to call that 40.5, 40.5 there for the mass on the 1. And then on picture 4, we put 250 grams of mass. Look at that line. It looks like right about 55 centimeters. So there we have 3 data points. We have 3 masses, 50 grams, 100 grams, and 250 grams. And we have 3 distances. It looks like 36, 40.05, or 40.5, and 55 centimeters. So now what we can do is we can, just like what we did earlier in the lab, we can put those into a chart and we can create a linear regression in order to find the K value. It should be linear. Okay. All right, so what about the third one? Well, in the third spring, we throw the 250-gram mass on there, and it does not stretch nearly as far. In fact, it actually stretches the same amount as 1. It looks like it's about 36 there, but the mass is a lot higher. This means the spring coefficient is going to be a lot stronger. Picture 3, we put a 50-gram mass on, and it is barely over 31, maybe 31.5. That's going to be really difficult to measure here because it's so far away from the ruler, but it looks like 31.5. And then they put a 100-gram mass on, and it barely goes past it. Maybe it's 32. So again, you have 3 data points. You can figure out the K value. Now that we know the K value, we can just, on picture 3, we can just measure the displacement. So here, I just look, how far is it displaced? How far did it go from its natural length here at 31? What's the X value? And then I can just plug that into Hooke's Law and calculate the mass. So I'm not going to actually do the problem for you, but I think I've given you everything you need in order to solve it on your own. So again, this is kind of a puzzle. We have a bunch of unknown K values that we need to find first. Then once we know those, we can find the unknown masses here in question 3. So hope this video helps and gives you a direction on where to go. Good luck. Have fun solving this puzzle.